Hello, this is a SolidWorks modeling learning assignment video number 1. As a part of this video, you are going to be building a simple part and then taking that and putting it into a drawing file to present. So, first of all, this is the structure of the modeling learning assignments is that you're just going to follow along what I do in the video. It's going to show that you understand how to use the program. You will need to do this work yourself. But we'll talk through that. So I've already produced a video on how to download SolidWorks. You will need to watch that if you plan on downloading it. Otherwise, if you plan on using a computer in our computer lab, then you wouldn't need to download SolidWorks for yourself. When you open up SolidWorks, this is the basic configuration. You may have a window that pops up in addition to this, but this is basically what we're looking at. If you go up to the top left corner and go into File, New, you'll have a window pop up. It gives you 3 different options, okay? And we'll talk a little bit more about what the difference is between these 3 in the future. In today's modeling learning assignment, we will be using the part and we will be using the drawing. So to start with, we're going to start by clicking on a part. We'll go hit OK. SolidWorks has to do a little bit to go set up a learning environment, a modeling environment for a part. So we'll give it just a little bit of time to think for itself. You may also notice that I'm using an older version of SolidWorks for these modeling learning assignments. Not really much has changed since SolidWorks 2018 has come out, so I wouldn't be too worried about the fact that, yes, this is a little outdated. The functionality of SolidWorks has really not changed since I started using it back in 2007, so there are a few nicer features and there's a lot of add-ons that are better, but when we go to develop a part, the idea behind a part is any single thing, any single component that can be made individually. Now, if I use an example of a part here, this is a carriage bolt, a nut, and a washer. All 3 of these together comprise an assembly, because by putting them on top of each other, well, this is one part, it is manufactured as one part. This is one part, and this is one part. If I remove them, I can hold them each separately. I can pull them apart. They're made similarly to this. Now, if you actually look at if you understand the manufacturing process of a carriage bolt, there is a weld involved here. This is actually 2 different components. This is a slender rod, and this is the head of the carriage bolt. So this is manufactured as a 2-part process. But we're only going to consider this to be one part because, again, like I said, in an assembly, assemblies are pieces that you can take apart and put back together, whereas a single part is something that may be welded, that may be fused together. You won't have parts that you take off of it. So just keep that in mind as you move forward in building SolidWorks parts and assemblies. So for our first piece, what we're going to be doing is we're going to be creating a very simple cylinder. We're going to have a flat, a flat edge on it. Now I'm going to direct your attention up here to these tabs. These tabs are your different functions in SolidWorks. This is a much more graphical interface than what you probably would have even seen in AutoCAD. So as a result, really what we're going to be doing is we're going to be using these 2 tabs a lot, the Features tab and the Sketch tab. Now, another thing that you need to notice is this piece right here is called the part tree. Here you have history of the document, sensors that may be put in, you may have specific annotations, you may have material types, you may have appearances, settings, you may have part details, and a whole lot of different things that get stored into this. And basically the entire building of this part and what comprises this part is going to be a sequential listing of components that show up in this list over here. Now the origin is for SolidWorks is set as the intersection of front plane, the top plane, and the right plane. You can even see the origin. If I hover over origin, it shows up as an orange dot. I can select origin, and now I have that point selected. I'll click over here to deselect it. So that's just some interesting features. You will need to know how to use those as we move forward. Now I'm going to go first and start off in the Sketch tab. When we do a sketch, this is very similar to AutoCAD. I'm going to go ahead and hit Sketch. Now, one of the things that you're going to notice pops up is sometimes it'll show top plane, right plane, front plane, and then you can pick a plane to draw on. You have to draw on something. For your first sketch, you almost never want to draw on anything that isn't top plane, front plane, right plane. If you do need to draw on that, what I would suggest is actually instead go into a feature, create a reference geometry, generate a plane, rotate that plane relative to another plane. But really for your first sketch, most of the time you're going to want to have it be on a front plane, top plane, or right plane. Another way of accessing it is here, your part list, your part tree, which is still visible right here, which would allow me to select all of those planes. It's also visible up here. If I hit this drop down arrow, I can select those 3 planes from here as well as the origin. So here, you kind of get the part tree here, and you get the part tree here. I'm going to go back into my, this is called the property manager. It's basically like a properties value for drawing a sketch. Now here I'm going to draw on the top plane. When I draw on the top plane, it's going to be in the XZ plane, so I can go ahead and click on it. Now navigating in this space is a little different from AutoCAD. My tendencies is to hold down the center mouse wheel and drag, which is what they do in AutoCAD, but you'll notice that the origin over here is kind of freaking out when I do that. It doesn't like that. What you're supposed to do if you want to pan is you hold down the control button and then you hit the center mouse wheel, and that's the way SolidWorks does it. So you have to hit the control button. Now I've got my view axes all screwed up. There's a couple ways that you can do to reset your axis. Here, if I click on the y-axis, it'll bring me back to the XZ plane. If I click on the y-axis again, it'll flip it over so I'm looking on the bottom of that plane. Similarly, if I click on the x-axis, I'm now looking along the x-axis, and then I can look at the back side of that by clicking the x-axis there. It really depends on how you want to look. Another way of doing it is up here at the top, you have the view orientation. So if I click on this, I can select top view, left view, front view, right view. And I can also click normal to surface. So if I have a plane that I want to draw on, and I don't care about what the orientation is, I just want to draw perpendicular to that plane, you can do that. So here I'm going to go back in here and select top plane. You'll notice it reorients it back to the X and Z pointing like that. This here is your origin. You'll notice up here this says I'm in a sketch because it says exit sketch. Also, if I go to the features, pretty much everything is grayed out. You'll notice that anytime you're in a sketch. If you jump into something, your sketch is going to disallow you from doing some things while you're editing it. Down here, you'll notice here this shows that we're currently in the sketch. The minus sign indicates that. This is at the bottom of the tree, which means this is the most recent item. I can affect everything that's above it in the tree, but everything below it is affected by the sketch. And we'll see that as we build more complex parts. So I'm back in the sketch menu. What I'm going to do is I'm going to create a circle. There's a number of ways that you can create a very simple circle here. But what I'm going to do is I'm just going to click, drag, draw, circle. I don't know how big this circle is. I mean, down here, it gives me parameters. It's apparently 2.87 units away from the origin, and it's 2.04 units in radius. None of that really means anything at this point. But those are interesting details that you can use. What you'll notice is that if I select the outside of the circle and I drag, it's going to allow me to change the diameter of the circle. It's actually really easy in SolidWorks to adjust component sizes and adjust component locations. I can click on the center of the circle and I can go ahead and move it to another place. Now you'll notice that the outline of this circle is blue. What that indicates that it is not fully defined. Not being fully defined means that I need to put a little bit more work into this in order to make this circle be completely dimensioned well. And there's 2 ways of doing that. Number 1 is what's called a smart dimension. So here, if I just click on this circle quickly, let's say I want this to have a radius of 1, so that it has a diameter of 2. I'll go ahead and type 1 in here, click out here, done, right? Well, the problem is that if in this course, if I accidentally grab this and move it, well, it's now changed again. So what I actually have to do in order to nicely dimension the circles, I have to use something called a smart dimension. The other thing is I can use display relations. We'll get to that in a second. So first of all, I'm going to click on this, pull it out. This is the diameter symbol. Right now it's saying it's got a diameter of 4.41. The moment I put down a smart dimension, it's going to give me the ability to identify what I want that value to be. Whoa, I didn't want it to be, oh yeah, I wanted it to be 2 inches. So there we go. So it is 2 inches. It's set as 2 inches. We are good to go. I'm going to click out a smart dimension. Now I want to take this and I want to put this directly on the origin there. There's 2 ways that I can do that. Number one is I can do a smart dimension and I can set the dimension in this direction, which is the X direction, and then in this direction, which is the Z direction. I can set both of those to 0. That's one way of doing it. But an easier way of doing it is to do something called add a relation. So here, I'm going to go to the center of the circle. You'll notice that the orange dot lines up. If I click on it, it shows up as 0.2. So in my add relations menu that pops up from clicking add relation, just here, the selected entities, one of them is now 0.2. If you select the outside of the circle, you'll notice that arc 1 shows up. And now I don't really have any options for what I can do with that, because you can't add a relation to both a circle and its own center point. That's kind of weird. So I'm going to need to delete out arc 1 and just leave the center of the circle. Now I also want to select the origin, and I want them to force them to be together. So I'm actually going to go back to my part tree, and I'm just going to click origin. And you'll notice that the origin now jumps into this. You can have them be so that it's forced horizontal, and I could establish a horizontal distance, or forced vertical, and then I could establish a vertical distance, or I can make them coincident. And what that does is it puts them right on top of each other. And I'm going to go ahead and hit enter. Now you'll notice that as soon as I did that, the circle outline turned black. If I grab on the outline of the circle and I drag it, it does not change the diameter of this circle at all. I will point out one relation that will always be available to you is this fix. Do not use it. It's not good. It's not valuable. It's really poor drawing design for you to add that relation. It forces it to stay at whatever dimension you're at, and it forces it to have whatever relations you currently have. It's poor design practice, and it's going to come back to bite you if you use the fix. So do not use fix. You'll notice that since we added that coincident relation, that relation actually shows up right here. And here it shows 0.1 at origin, so it's relation to the origin, and then 0.2, which was the center of our circle. Okay, so this is done. I'm going to go ahead and exit the sketch and say, okay, I'm done with that. Done drawing a circle. And now what I can do is, since I have a sketch, you'll notice I have it selected down here in the part tree. I'm actually going to intentionally deselect it. But I have this sketch. I have a number of options that are now available to me in this Features tab. I can create a revolved base. I can create a swept base. All of these mean something. We're going to be talking about them in future videos. I can also, like I said earlier, add a new plane, add a new axis, points, all of these fun things. There are certain types of curves like a helix that you can generate that are three-dimensional curves. All of these are things that I could draw now, but I just want to take this shape and I want to extrude it. I want to make it into a solid. So I'm going to go ahead and click on the extruded boss base. Now here, because I deselected that sketch, there's 2 ways that I can do this. I can either click on the outline of the sketch, which will bring me to the sketch, or I can just bring down my part tree again and click on sketch 1. And notice it'll spend a little bit of time to think. It will add sketch 1 into the selected contours. So that's important. If you only want a certain feature out of a sketch, you can also do that, like enclosed feature 1 out of sketch 1 if you really want to. Usually it's best to keep 1 feature per sketch, but we have a number of options that are available in our Boss Extrude menu. So first thing I'm going to point your attention to is the direction. So here, a blind extrusion is something that it goes straight up, it goes a certain distance only as far as you tell it to go. Blind extrusions are really good when you're making individual parts, very simple parts. But some of these other options give you other abilities too. So here, if I say I want this to be 4 inches long, then you'll notice that this is now a 4-inch cylinder. And the yellow here shows you kind of the preview of what it expects to build. But I could also do something else. If I had a number of surfaces, like let's say I had a vertex that's an intersection of something, I could extrude up to that vertex, and then I wouldn't need to give a distance. I can extrude up to another surface. So here, if you have a metal bar that you're extruding into another metal bar because you're going to connect them together or something, you can extrude up to a surface. You can also offset from a surface. So if you are extruding up to, but really close to, but not quite to a metal bar, you can offset a surface that way and then extrude to that offset. Similarly with a body, it's just like up to body is up, just like up to surface. Mid-plane extrusion, what it'll do is it'll say, here's the drawing. I'm going to extrude half of it to one side and half of it to the other side. So that can be really helpful if you need to have the origin located at the center of a part. Sometimes that can be really helpful. For me, I don't really need the origin to be at the center of this circle. I actually want it to be on one face. So I would prefer for it to be blind. So here's my origin 0, 0, 0. It's going to be located right there. I want it to extrude out 4 inches. Now we have a couple of other features that we can look at. This is called a draft. What a draft does is it allows you to put kind of a taper on the extrusion so that here's our original drawing, and then it tapers down to a very, very little circle up here. And I think you can actually keep going too to make it, yep, it turns into a cone at some shape, which is kind of interesting. Similarly, I can hit the draft outward button and say this is the shape I want, but I want it to have this kind of a feature and I want it to get much bigger as it goes upward, and you can do that. I don't want to have a draft here. The other side is that because we're extruding this direction one way, I can select direction 2, and what that means is now I have a direction here where I can extrude down to a surface, or I can extrude a certain amount of distance, and that will allow me to keep my origin at this location at the part. If maybe if you're making a complex part where you need the origin to be here because maybe there's going to be a bolt head down here or something, this could be a really useful feature. I don't want direction 2, so I'm going to delete that. Similarly, there's something called a thin feature. What a thin feature does is it will only extrude the line, but it'll extrude a small thickness next to that. So it'll extrude the line and it'll make it 0.10 directions. And here this is currently in one direction, which means it's a boy band, really. But actually what it means is that here's our original contour, and it is extruding out here. So if I flip the direction, you'll notice that now it's extruding inside. So my 2-inch diameter circle is now the outside, whereas if I hit this, now the 2-inch diameter circle is the inside. And the wall thickness here is 0.1 inch. That could be useful. And then you can also cap the ends, which just basically means that it creates a solid surface inside of it. So it looks like it's, like a can. So just another interesting feature. Again, I'm not going to be doing thin feature today. I want this to be a completely solid object. But I'm going to go ahead and hit OK. Now, what SolidWorks is going to do is, first of all, it's going to fill all this in. I'm going to pan over so that I can see this a little better. But it's also going to replace my Sketch 1 with Boss Extrude 1. Now you'll notice that if I drop down Boss Extrude 1 includes Sketch 1. And Sketch 1 is required to build Boss Extrude 1. So it just kind of hides in there, nests itself into that feature. One of the nice pieces about that is I can go in, I can select this, and then I can edit Sketch. So here, let's say I don't want this to be 2-inch diameter, excuse me. I actually want this to be a 3-inch diameter. So if I double click on that dimension, I can now go in, hit 3, hit enter. It's going to make the circle wider. I'll hit yes. You'll notice it actually takes away the preview. Go ahead and hit exit sketch. I'm exiting this sketch right here. And then it rebuilds the part with the feature parameters that I put into Boss Extrude 1. So it takes the profile that it had already had, it adjusts it, and it expands it. So SolidWorks is really made for being able to edit these pieces. So here, if I want to go edit the feature and I want to make this a little shorter, instead of making this 4 inches long, I'm going to make it 1.5 inches tall. So about the same height as the radius is. So I just clicked on that edit feature. This again goes back into showing me the preview of it. If I select 4 and I set this to 1.5 and hit enter, well, I have now completely changed this part, and all it took was going into the feature and going into the sketch and just changing one dimension either way. So again, SolidWorks, it's really versatile. It's meant to be something where you make an iteration, you change it, you adjust it, you add on to it, you build onto it. And that makes it a lot nicer than AutoCAD in this way. When SolidWorks was first created, Inventor had to include a lot of this functionality in order to try to keep up with SolidWorks. So it's kind of interesting. So now that we have this shape, we're going to add one little extra element of complexity. I'm going to go ahead and do a sketch, another sketch. This is going to allow me to build another feature. So I'm going to go ahead and click Sketch, go into Sketch. Now once again, I could draw on this top plane just like I was doing. I could draw on the right plane, I could draw on the left plane, I could draw on any plane. These 3 planes here are highlighted. But what I actually want to do is I want to draw on the top of this component so that I can cut out a piece right here. So I'm just going to click on this flat face. It doesn't have to be a flat face, but I'm going to click on it. You'll notice that the origin projects onto that face so that now we have an origin for this new sketch. This again signifies that I'm currently in the sketch. This also tells me I am currently in a sketch. Now what I'll do is I'm going to go hit my view orientation, click normal to, and it'll automatically go normal to my sketch plane that I'm working on. Now what I want to do here, thank you for notifying me that I haven't saved, is I'm going to draw a rectangle, because I'm going to use this rectangle to create a notch. There's tons of different ways of doing this. I just happen to be doing it this way. So here I've drawn a rectangle. I'm actually going to cut this rectangle out of this component to give this kind of a flat face. A lot like a cotter key or something that you would well, like a keyway piece. Words. Now what I want is, I want this rectangle to be in the center of this piece here. I could again do a dimension where I could say, okay, well, I want this to be this far away from this one, and I want this one to be this far away from this one. I don't really want to use a dimension here. I like using relations as much as possible, because relations say, well, I want the center line of this thing, which if I hover over the center line, eventually the center line shows up, and then this symbol down there actually signifies that is a center line, a center point. I'm going to go ahead and click point 1, and then I'm going to go ahead and hover over the origin. The origin turns orange, I select that too, and what I'm going to do is I'm going to make these vertical. So what that means is if I grab onto this edge over here and I drag it in, if I maybe make this rectangle longer or shorter, it's always going to stay in the center, so it'll be nicely and evenly centered in this. Otherwise, you may have one side that's way out here and the other side is way in here, and I will never want that out of this specific rectangle. And what I'm also going to do is, hitting it OK. Then I'm just going to add a dimension here where I'm going to say this side I want it to be, I don't know, 1 inch. So whoa, click on Smart Dimension. Click on this line, pull it out, type in 1 inch. And then I will pan up here by hitting the control button and the center mouse wheel. And let's say I want this one to be pretty thick. I'm just going to put this one as 4 inches. Why not? And I'll drag it up here. You'll notice SolidWorks is running really slowly on my computer. It is not liking me live streaming while playing with SolidWorks. So set this as 4. Okay, and then let's say I'm going to dimension this side too. And drag it down. You notice I get an error sign here. Because I'm working with a rectangle right here, the relations that already exist added with this dimension says that I'm trying to force this side to be 4, but these are all right angles, and I'm trying to force this to potentially be a different number. So what SolidWorks will do is it'll give you this error message, and it says, well, do you want this dimension to be driven? And what that means is if you hit OK, the dimension just kind of sits there, grays out, and it doesn't do anything. It'll react if I add another dimension or something. But really, it doesn't do anything. It's telling me that if I were to create this dimension and say try to set this to 5, it couldn't build the drawing the way that it was already made. So again, it's useless. This is a useless dimension. So what I will do is I'm going to go ahead and select this and delete it because it's not useful. If you get the error message, I would just exit out of there, try to get rid of it. If I deleted these relations here, which force these lines to be vertical, then I could change the distance here, and I could get really funky with that too. But as of right now, I want to keep these relations in place. I want this to be a rectangle. But you'll notice it's still blue. Well, and that's a problem. Well, part of it is if I grab onto this blue line and I try to move it, it moves up and down. I haven't defined where its vertical position is. So I am going to define its position relative to the origin. I'll go ahead and click Smart Dimension. I'm going to click on this line. You'll notice it pops down as 4 and it says, whoa, I don't want that. But if I take that line, dimension it, click on this center point of the origin here, it then gives me a different dimension from this line to that origin, to which I could set this to 1 inch. And then I will exit the Smart Dimension. You'll notice my rectangle is fully filled in, and I'll go ahead and hit Exit Sketch. Wait for it to update. Just waiting. Wait. Okay. Exit Sketch. Try again. Come on. Computer. Do what I want you to do. There it is. You'll notice the moment I exit the sketch, all the dimensions go away. Why is that? Well, it's because SolidWorks knows what those dimensions are, and if you have a ton of dimensions on here, it ends up getting really messy very quickly, and you don't really want that. This is not intended to be used for creating the professional displays. Certainly not the way that we did it in AutoCAD. What I'm going to do is I'm going to go into Features, and then I'm going to take this, and I'm going to do an Extruded Cut. You'll notice that now that we have an existing solid feature, a lot of these are also available now. We could do a wrap, we could do a linear pattern, we could really play with this existing feature and make it do a whole lot of stuff. But I'm going to take this sketch 2, which is currently at the bottom of my tree, and I'm going to go ahead and do an Extruded Cut. What that'll do is it'll take this profile, and it'll allow me to cut a certain distance. Here, once again, we have different options that we can do for an extruded cut. We can do through all, which is what I'm going to do. It means anything on either side, well, anything on one side of it gets cut. What I'm going to do though is I'm going to do through all both, which means anything on either side of it are going to get cut. Doesn't matter, anything that exists above it on this part tree, which would be, we only have one component right now that's above the part tree, which is the boss extrude, but anything that exists in the part tree above this feature is going to get cut if I do the through all both. It will not cut future features, so I could add on to it later, but this might be a nice way of creating a flat surface to draw on. Once again, I can do a thin bevel, and I can also do a second direction too, although here it has through all set because I picked through all both. We can also do a thin feature, which what it does is it cuts just the line, and you can specify what that line distance is. Ends up leaving some parts there. That can be useful. In here, again, I can pick a selected contour down here, which I have as sketch 2. So we'll go ahead and hit yes. Oop. Accidentally changed this. My bad. So we'll go ahead and hit yes. And what you'll notice is that it does chop that piece off. And now I have a flat surface that I could potentially draw on, and then a rounded chunk. I'm going to go ahead and call this good. I'm going to do File Save. Now I'm going to want to name this a unique name. The structures for this, for SolidWorks, they have to be fairly rigid. As we get into assemblies more, we're going to be talking about exactly what you have to do to make a part nice. Because building assemblies is very challenging at first in SolidWorks, so you have to do it right, or you can really mess a lot of things up. So here I'm just going to call it MLA1. I'm going to put it in a folder called MLA so that I can put all of my MLA stuff together. I'll hit save, hit yes, because that part already existed. And there we go. Now, in order to make this presentation quality, I need to go up in here and do new. So I'll go up to new. Here I said we were going to use part and drawing. This is a part where we're actually doing a drawing. So drawing has a very specific feature. We're going to go into it right now. So now that we've created the part is still open, but we're going to be opening up the drawing interface, which will allow us to actually draw on the part itself. Well, draw using the part itself and create some very standardized features. Now I have posted a sheet format on Canvas. You will want to download that. Once you've downloaded it, I don't know why I clicked. I don't need that open. Once you've downloaded it, what you'll want to do is you're going to go browse for it here. And we're just going to set the standard sheet format to that that sheet format that I gave you. So we'll go back into my folder where I have these, and then down here I've got Don Eng format, Eng sheet format. Open that up. You'll notice that it pops up. It's got the symbol, it's got the template, it's already built out. I'll go ahead and hit OK. This tells me all of my sheet sizes that I already have, and it kind of puts it there all in place. Now the first thing that it wants to do is it actually wants to pop open this. I have MLA1 open, so if I just click yes, go for it, it's trying to put in a model view, which is in the view layout. If it doesn't automatically do that, you can just click on view layout and click model view. If I double click on this, it will ask me where I want to put in the drawing, and then it's going to give me a front perspective of that part. But you'll notice in the front perspective, it's very circular. Now the nice thing about putting in model views is that model views allow you to create a three-dimensional, three-view piece just by dragging up. So I put down a model view. I haven't hit escape. I haven't clicked another time. But when I drag my mouse up, it gives me now, this would be a top view. If I go over here, this is now an isometric view. And you can see on the side of the page that it actually is changing the view orientation. Well, I guess you can't really see it. It's kind of a little bit down on there. But this is now a right side view. This is another isometric view. This is a bottom side view. This is another isometric view. This is a left side view. This is another isometric view. So depending on how you drag away from this model piece, it's going to allow us to put down different types of views. I'm going to put down the standard 3 views, which is the top, the right side, and the front. And then I'm going to put down one isometric view. So I'll go ahead and click up here. Okay, and those are going to be my 4 components. You'll also notice that it's trying to add more. I'm going to hit escape, get out of this, because I'm happy with what I have. Now you can actually drag your isometric view. Once you've put it down, you can drag it to a nicer spot, because it never shows up in a nice spot. But if I try to grab this and drag my left side view, I only am allowed to drag it left and right. I can't drag it up at all. And similarly with my top view, I can only move it up and down. This is linked to this center view, which is the model view, and these are called projected views. So this is a projected view, this is a projected view, this is a projected view, and this here is your model view. It's kind of the driving view that defines everything. If I go in here, this is called the parent. If I click on this, I can set scale. So here, if I go down here and I want to use a sheet scale. Sheet scale is currently set at 1:1, or I get to identify a custom scale. Maybe I want this to be a 1:2, which would shrink this one. And because these all use the parent scale, it's going to shrink them too. But I actually want to just go ahead and use the sheet scale of 1:1 because it fits nicely in this space. You can change a few other things. You may want these views to be line views, which are really standard in SolidWorks. But this isometric view, I don't want this to be a line view. You may sometimes want it to show the hidden line. So here it'll show the back sides of it in the corner. But you may also want this to be a shaded view, which gives it a little bit more perspective. Kind of shows it as a more of a solid feature, especially if you add a color to this part, it'll show up in the shaded view. So this is the very basics of how to put together a simple sheet. We're not going to put on dimensions yet onto this. We're not really going to talk about annotations yet on this. That'll be done on a different video in the future. For right now, your first modeling learning assignment is you have to give me this. Now you will have to come down here, double click on your template. Here I'm going to go into name of drawing, and I'm going to go ahead and call this MLA 1. And for MLA 1, the description is going to be round component with flat edge. We'll go down here, drawn by, double click. Maybe it won't let me. Oh, that's interesting. That's interesting. Well, here it's got the date set in. It's scale 1:1. This is the sheet scale, and it's already got the sheet number 1:1. And right now it says inches. Here I don't have the drawn by, and the reason for that is because in order to add that component, I have to go up into my, let's see, where is, looking for the properties of the drawing. Where is that? Is that in options? I think it's in options. Maybe in options. I know there's a number of things you can change in options. This is great. Getting to the end of the video. Document properties? Nope, that's not it. Although that was fun. Let's see. Oh, there. It's in the file menu. Here, it's properties. Okay. And here, I'm going to go ahead and call the author CJS. Well, that's my initials. Although you can go into custom, new property, and I can pick from, if you are working from a template that's already set up, you can have pre-existing properties. I'm going to go ahead and hit author because I think that's all it takes. Yeah, that's all it takes. So you'll have to go to File, Properties, and then put your name in the author. You can add a bunch of other stuff. A lot of this stuff will show up in the file when it actually gets saved. Not a bad idea to have some documentation there, but I'm not requiring it for this. And then that's what you have. You insert the name, you insert this piece here, you insert your name, your initials. It'll automatically fill in the date. It'll automatically fill in these pieces. As long as you have these 4 views, this is what you hand in. Now, in order to print this, this is a little simpler than doing it with AutoCAD. Here, we're going to go ahead. You can publish to eDrawings, which is kind of cool. But this is called print. So we'll go ahead and print this. We're going to print all sheets. And instead of printing to anything else, I'm going to do Microsoft Print to PDF. Or you can also do PDF Report Writer, or just something to print to PDF. I wouldn't change any of the rest of these. Just make sure you have all sheets selected, especially if you have multiple sheets. This can force everything to come out in black. Because we're printing to PDF, we don't need it to be all black. So if there are any colors, I appreciate that. You go ahead and hit OK. And then it'll start printing your PDF and allow you to save it. So here, if I go back and try to save it in this folder, Then I can just go ahead and call this MLA1 and hit save. It'll give me my printing piece, and then it should pop up the PDF viewer and show me the PDF that it created. I assume. Maybe it doesn't. Maybe it's still working on it, I don't know. I'm gonna go try to find the file. Just to show you that it actually did what it said it was going to do. MLA. Here we go. So yeah, apparently it did save it, it just didn't auto pop up. It's weird. You notice it's got all the elements. Here, these are just flat lines. This is shaded. These are our elements down here. We're good to go. So that's how to do a simple part and document it in SolidWorks. You'll be handing in this PDF as part of this